Lights, camera, action. Welcome back, folks. My name is Ash, and you're watching me on Career Terminal. So, today is the day 2 of our 20 days Java course from noob to pro. So, today we're going to learn what variable is, and this is going to be a simple concept, but at the same time, don't neglect it because I've seen many big people, senior most people, make mistakes in this because they think this is too easy for them to invest time on, and they don't invest time on this. So I've put this as a separate day where we will be going through what variables are, what strings are, what are the methods in string, what is typecasting. So let's get started. So a variable is like a labeled box in memory. You give the box a name, tell Java the type that is be fit inside the box, or you can say like tell Java what type of thing it will hold and put a value inside. So what Java will do is Java sets aside exactly the right amount of memory space for that type, no more no less. Let's get started. So guys, what is variable? See, a variable is like a labeled box in memory. You give the box a name, tell Java what type of thing it holds, and put a value inside. See, Java will set aside exactly the right amount of memory space for that type, nothing more, nothing less. If you want real life analogy, everybody knows RAM, right? The one thing that is skyrocketing. So think of RAM as a huge warehouse with millions of tiny boxes. Each box has an address, right? Everybody knows that. To index it, to access the location of that RAM, you need to have an address, right? And that's how all the computers access RAM. A variable is your human friendly label on one of those boxes. Imagine, instead of saying go to address 4A76, you say go to the box named age, or go to the box named date of birth. So this is the reason why we have the concept of variables in the first place. So we are going to see a demo of what variables are. Let's get directly into the coding. I'll execute this and I'll step by step explain you what the things are. So this is again the code I generated using AI. So in our channel nobody writes code. Let's get started. So if you want the prompt to generate this, it is very simple. Write a Java code for understanding variables. You can name the class as variable demo. So this simple prompt will work, and let's get into that. See, in the previous videos we have covered what these means, what are the meaning of first and second line. So let's skip that. Let's get into the method. So see, int, you can see int over here, right? You can see double, you can see char, you can see boolean. So all these are actually data types. I told you, right? You have to assign a data type and then put the value inside. So this consists of three things. This is a data type. This is the name that you are assigning to the variable. This is, you can call this as a variable name, and this is the value you are assigning. Now the math is very simple. See, when you're putting any integer, you call it int. When you're putting any decimal numbers, you're calling double. There's something called float also. We will explore that. And when you're putting any character inside, you call it char. And for true and false, you call that boolean. So observe, here it is integer, and here it is int, here it is double, here it is double. So what if I tell you double price 2 equal to 15.99. Why didn't it give an error? Why is this data type? I told you, right? Java is case sensitive. How can double have two doubles with small double and small d and capital D? And why the hell is this in this colored, and why is IDE considering this as not colored? If you observe variable demo and this, are colorless. There is nothing, there is no color. And one more thing, if you observe, string also does not have a color. What's happening? Let me tell you. So see, int, double, char, boolean, the ones that are starting with small letters are called primitive data types. And this double, the capital D, the capital, even integer has a class. So if it starts with capital I, if it starts with capital D, or if it starts, string does not have a small s. So string you have to start as s. So what is the difference between the capital D double and the small d double? So the small d double over here is called a primitive data type. And the capital D over here, as you can see, this is a class. This is not a primitive data type. This is a class that some developer has created and we are using it. So the difference between the capital D double and the small d double is the small d double is a primitive data type. So what exactly is a primitive data type? See, they can be considered like the simplest building blocks. So whatever you store in a primitive data type gets exactly stored directly in the memory. But when you use this thing, that is price2, which is having capital double as the data type, but this is not a primitive variable, it is actually a class. If I hover on the double, you can see nothing happens. But if I hover on double, there is a pop-up which says that this is a class called double. Why was this introduced? I'll tell you in the later classes. Main reason is to make your life easier. So going forward, I'll be explaining you in the next classes what class is, what's an instance of a class, what are objects. So don't worry about that for now. Let's focus on variables. So guys, you might have a question right now. So how many primitive data types exist? So I've created a simple thing using AI only. So see, okay, I can't show this one. Stop. So guys, there are exactly 8 primitive data types available. Those are byte, short, int, long, float, double, char and boolean. And here on the screen you have the respective sizes available, ranges and the default value. This default value is important. You will have to know this, especially for boolean equal to false. This, when you're writing or creating applications, right, you have to remember this. So this is more important than any of the other things. So a default value for boolean is always false. So these are the examples how you can assign them, and the main thing that you have to focus in this image is the size and the range values. So guys, you have to focus on size and range / values on this image. So observe here, we have all numbers here. For the first 4 rows we have numbers and there is no decimal value in this. The next 2 has decimal value. So why do we have 4 different data types for numbers, storing numbers? The answer lies in the size. Remember I told you the box analogy. Once you create a box, you cannot change it. So think of like a wooden box. You create it, that's rigid. There is a specific number of coins or anything that you can store in that. So like that, imagine you want to save space. You have to put only 1 coin. You won't make a box as big as a mountain, right, for saving 1 coin. So that is the reason you assign byte when you want to save a small number, and short for little bigger, int for more bigger, and long for the biggest. Now coming to the decimal, we have the same equation here. For if you observe float has 7 decimal digits and double has 15 decimal digits. So even decimal numbers will occupy positions, right? Even though they are not significant in making the numbers huge, but when it comes to the memory and saving the numbers, they still are counted as digits. They still need the positions to fill. So 7 digit and the 15 digit has a size nearly or double, right? 4 bytes and it is 8 bytes. So this is the reason why we have 4 different data types for numbers and 2 different data types for saving decimal values. So as a summary, you can save more decimal values in double than in float, and you can save the largest number in long than in byte. Now you have to remember this for the later part of the video, where we will be talking about typecasting, which is very important concept. Here also people make a lot of mistake. You don't make it. So the next thing, let's go to the next thing, that is char, which stands for character. It occupies 2 bytes, it needs 2 bytes, and it follows Unicode. We will talk about this later, but simply you think that it will save characters in it. Next is Boolean, which, as I told, it saves false and true in it, and it takes only 1 bit, 0, 1, right? That's it for the primitive data types. Now if you observe one thing here, there is no string over here, right? Let me tell you why. So guys, back to the program. See, the string over here is again not colored. String is a class. When I hover on top of this, it shows that this is public final class string. So string is not a data type. Hence, we have so many methods that you can use with string. So I have a string demo planned. I'll be talking about this in few minutes, and post that I'll be teaching you what is typecasting. So let's execute this thing and let's see what this code gives. So the output is something like this. We have seen all this. Boolean is Java, we are saving it as true, and string we are saving as hello world. Now we are printing. We have seen this thing in the previous video, right? How to print and what does ln mean. So system.out.println, we are explicitly mentioning that we have to print greeting, and the greeting that variable name, this greeting is the variable name, and we are assigning this variable name as string and storing hello world in it. So this will technically print us greeting and hello world. Same thing with the age, same thing with the price, same thing with the grade, and is Java fun? We are updating it as true here. So it says that it's true. So this is simple printing that we have seen in the previous video. Now let's come to can we update it? So this is kind of important. Why? Because I'll tell you about that in the Spring demo. See, age, we were updating it as 25. Now the age is 26. And we are printing the age again, and we are saying the updated age is 26. And it was able to change it because the reason being, the data type, primitive data types are saved in the memory. So you can access the memory and you can change it. Now when it comes to string, right, string is a class. So string is called as immutable variable. So this is a data type that you cannot change. Now let us completely focus our attention on string. So string is not a primitive data type, as I told you. So string is a class and it has a lot of methods. So let's explore all the methods. So this is a program. I would like to execute this before explaining you, so that it will be easier for me to explain. Okay. So guys, let's go to the start of the line. We can ignore these two and jump to the line number 5. So what we are doing here is we are creating 2 strings, one greeting and one target, and we are assigning the values. One is hello and one is Java programmers. Now coming to the line number 9, what we are doing is something called concatenation. So we are using the previously created strings with new strings, the in quotations, like we are adding a comma, space to this string with exclamation mark at the end. So let us see what it has given. So this gives something like this: the hello from the greeting, and there is a concatenation that is happening, comma and space has been added, and the Java programmers from the target has been added to message. How do we know? Because we are printing the message here. Now I told you about string methods, right? So there are methods which help us to understand and modify strings. You cannot modify the string. There is a catch here. I'll explain you once I finish this thing. So to know what is the length of the string, we can use the method called length. So what we have to do is whatever string variable name you have created. So this is actually not a variable name. This is an object now. We will understand objects in the later classes. So that is the reason I am explaining this as I'm calling this as variable name. So let's go with variable name for now. So message dot length. So this will give us the number of characters, what is the length of the string. Now let's count. Let's see if this has given a correct number. So 1, 2, 3, 4, 5, 6, 7 space 8, 9, 10, 11, 12 space 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So exactly there are 24 characters. So the length of the string that this method has given is 24. It's matching. Now when you want to change the case, like hello, we are converting this string into complete uppercase and complete lowercase. These are the output respectively. Now coming to finding a character or a substring. Now this thing, the char at 1 will give us what is the character at the first position. You know that, right? In programming language, 1 is not the number that it starts from. It is 0, where everything starts from. So H is actually at the 0th position, E is at the first position. So when we give char at 1, it will give us E. So it has given E, and this method dot contains. This method we are asking if this string has something called Java in it. So does this have Java in it? Yes, it does Java in it. So what it returns? It returns true. Now next thing is important. This is called comparison. Now there are two strings that we are creating, S1 and S2. The difference is nothing but one variable change, which here it is capital J and here it is small j. Now we are asking this method to check if it is matching or not. So S1 dot S2 should match, right? Java, and this is also Java. But here's the catch. So because of change in that one variable at the start, it starts with capital J, it starts with small j, it will return false. So this equals method is gonna be like the strict principle. When the strict teacher comes for evaluation, you cannot cheat or you cannot do anything, right? So it is like completely strict. So even a small change will not be allowed. So when but there will be certain times, right, where you want to compare and you want to check if they are matching or not. No, it doesn't matter about does it have a capital letter or small letter. So in those cases we say equals ignore case. This is very essential when you are creating an application, because most of the times you don't know what the user will send. Now let us understand what typecasting is. So for this, let us take our wooden box example, and for simplicity let's assume that wooden box is in the shape of cube. It's a cubical box, and you have two cubical box, one smaller and one bigger. Now the smaller box can be easily placed inside the bigger box, but the bigger box cannot be placed inside the smaller box. So similarly, your byte, which is smaller than short, which is smaller than char, which is smaller than int, and which is int, which is smaller than long, also follows an order. That means if you have a box called long, this can accommodate byte, short, char or int, but int box cannot accommodate long. So this is called widening casting or automatic casting. So automatically your box will not fit, right? But with alterations you can do that. So those alterations are called narrowing casting or manual casting. So let us see the example. First let us run this program and let's see the example for widening casting. See, widening casting, I'm trying to change an integer to double, and automatically just I'm assigning it to the double variable, and it is making 9 to 9.0, right? Now coming to narrowing casting, what I'm doing is I'm assigning a double value to int, but I am mentioning that this is called explicit casting also. So I'm explicitly mentioning that change this double value to int and save it in int variable called truncated pipe. So if you see 3.14159 becomes 3, there is data loss that happens. So keep in mind, this comes with a data loss. So whenever you are writing your application or creating your application, Just keep that in mind. There is one more pitfall over here during typecasting. So for example, let us imagine we want to change this 130, which is an integer, to a byte value. So byte has a range from -128 to 127. So the question is, how does 130 incorporate? Let us see what is the printed value here. What the printed value is -126. How did 130 become -126? So the catch here is, see, internally there is something called two components that happens, but let's not get into that. I'll give you a simple analogy how it happens. Just think of a circular racetrack and place -128 to 127 on the track. So after 127 we have to say 130, right? After 127 it's not 128 that comes, it is -128 that comes, because the circular track, right? So 128, after that it is -127 and -126. So that is the reason we get -126 when we try to manually cast 130 to byte. So that's it from typecasting, and I'll tell you some rules that you have to follow. Now let's get back to our strings, because see, there are some naming conventions that you have to follow. First, remember, every time when you're creating a variable, it should start with a letter or underscore or a $sign. Never try to start with a number. See, it will give an error. If I try to make 1s1, it's not gonna accept it. Second thing is, you should never have a space in between the variables. So imagine if I have something called learn Java carrier terminal, I will not have spaces in between that. So how will I know that? Like, imagine if I just write it in one word, how will people read it, right? There is a problem in readability. So to avoid that, we use something called camelCase. That is, so for example, if I have to write learn Java carrier terminal, I'll start with lowercase, then for the next word of the first letter, I'll write that letter in uppercase, and I'll continue the same thing. So folks, that's it for today. We can wind up the variables concept and meet you on the day 3. Thank you so much. See ya.